Thank you. So, every time you open a newspaper these days, you will find amazing stories like this one. How big data can make you happier, how big data can make you healthier, and how big data keeps planes flying. And we probably wonder, how do we fly before big data? And of course, only this is partially true. We have a lot of hype, and we have a huge amount of jargon. And this jargon is the one that generates a lot of hype, because with jargon, you have people talking about things they don't understand to people that don't understand what the other things are. So you generate confusion. This confusion leads to hype. So the first question I want to try to answer today is why we have so much jargon. And I believe this happens because of two reasons. The first one is we are addicted to complexity. We like complex projects. That's probably the reason why we put a man on the moon before we added wheels to luggage. This is true. And the second one is that we want to look more sophisticated than what we really are. If you go to Starbucks, instead of having small, medium, large, you have tall, grande, and venti. And something as simple as this, even though definitely works for Starbucks, generates enough confusion that you have people online searching for the coffee sizes. And go to a Starbucks and ask how many people actually get what is tall, grande, and venti, and not everybody actually get it. So imagine that something as simple as coffee sizes, where the universe is only 3 results, small, medium, and large, you generate enough confusion in people that people go online searching for this, and there are websites that describe what is a coffee size. So this desire to look sophisticated plus the addiction to complexity generates this jargon. Jargon generates hype. And too much hype leads to confusion. Dan Ariely is a professor of behavioral economics at Duke. And he says this very clear. And I quote, "Big data is like teenage sex. Everybody talks about it. Nobody really knows how to do it. Everybody thinks everyone else is doing it. So everybody claims they're doing it." So that's the first question we try to answer today. What is big data then? Because everybody talks about big data, but what is big data? And if you go online, or if you want go to some of these conferences about big data, you will have listened to people talking about big data definitions that start with the letter B. And this started from Doug Lane in 2001. He defined big data as velocity, variety, and volume. And from 3 Bs, we went to 4 Bs, to 5 Bs, to 6 Bs, to 7 Bs, to 10 Bs. We're seeing an exponential growth of big data definition, and all of them start with the letter V. And I'm not saying they're wrong. I'm saying that they just add to this jargon. And there's only one thing that is worse than jargon, and it's jargon that starts with the letter V, basically. They also miss the point. Big data, the objective of big data, is to be able to solve problems with data. This is what really matters. And a lot of these definitions just focus too much on the size of data and how much data we're generating, but they forget that at the end we want to solve problems using data. And the issue here is that there's nothing new in solving problems with data. John Snow, back in 1854, using data from cholera cases, was able to pinpoint the cholera outbreak in London. So if we want to understand what is different now, if we want to understand what is big data, we need to understand what is different now. And there are a few things that are different. The first one is true. We're generating a huge amount of data. Every single day it's estimated that we add 1.5 million times of all the content of the Library of Congress. So that's definitely true. The second one is that the cost of storing this data has dramatically gone down. Today, with $3,000, you can buy enough storage to store every single book that was written in human history. Something that would have cost over $1 billion in 1984. Something that will probably cost less than $100 in a few years from now. The cost of storing every single word that you will say in your lifetime, that a person will say in your lifetime, costs only 15 cents today. On top of this, the cost of the processing power that we need in order to process this data also has gone down. In your smartphone today, you not only have more power than the computer that put the first man on the moon, but actually more processing power than every single mainframe that NASA had back then. Your Xbox One at home has more processing power than a supercomputer that NSA bought back in 1996 that cost $67 million and has 6,000 Pentium Pro processors. Your Xbox One at home has the same processing power. But at the end, we need to remember and understand that big data is just data. And what matters is what you do with the data, nothing else. So what we're going to see today are 4 different topics. The first one is the common pitfalls of big data, the need of experimentation, the concerns and risks, and how do we see the future. So the first one is the 6 common pitfalls of big data. The first one, like you say, is we focus too much on size of data. Everybody talks too much on the size of data. We are obsessed by size. The other day there was a panel of experts and people were discussing, well, it's not big data if you can open it in Excel, or it's not big data if you can store it in a single server. It's not about size. It's never about size. In some cases it could be, but in this case it's not. We need enough data to solve a problem, but we need to focus on the problem. There are, for example, 1,000 people well-designed survey will provide you a much more accurate number. For example, if you want to try to predict the next presidential election, 1,000 people survey that you can actually fit in your smartphone, you will be able to answer that question much better than a 50 million opt-in social network, data that you get from a social network, because of the bias. Nate Silver, who is a very famous statistician, did all the models that he did. He rightly predicted the last 2 presidential elections. All the models and all the data he used, you can store it today in your smartphone and you can run it from your smartphone. It's not about size of data. You need enough data to solve a problem. Some problems will require a huge amount of data, but some problems will not. The idea here is that we need to focus on solving problems. What really matters is what we call big data, but with W. That is big impact with data. This is, at the end, what really matters. Second one is too much focus on technology. Everybody talks about, when people talk about big data, they usually refer it to technology, like Hadoop or things like that. And Hadoop, for example, is a great piece of technology that will allow you not only to store data, but also to process data. But at the end of the day, it's not magic. These are great technologies, but by themselves will not do anything. You need actually people doing something with data. My concern is that if you take a look at the ecosystem today, majority of the investment we have is in infrastructure. And I can tell you that if you have the money to buy the infrastructure, the difficult part here is usually not the infrastructure. The difficult part here is to actually getting value out of data. That's what really matters. And at the end, you will not have ROI from a project if you don't do anything with the data. Just collecting data will be useless. Pitfall number 3, and we have 3 more. We forget about bias. In October 2012, during Hurricane Sandy, there were over 20 million tweets that talk about the hurricane. And this is an excellent data source. And a lot of researchers use it, for example, for understanding how did people behave during the hurricane. When did people went grocery shopping? What was the nightlife about? But like Craig Crawford mentioned in her paper, the problem is that you have a huge amount of bias. If you take a look at some of these tweets, if you take a sample of those tweets, you will get the impression that things were not that bad. People were going out, people were enjoying the fact that they didn't need to work. It doesn't give you the impression that things were bad. But what's the problem with this data? Majority of the data was generated in Manhattan. That's the first bias. Second bias is that the population that was affected by the hurricane is probably not very well represented in the population that used Twitter. And the most important bias, if you had enough time to tweet, probably things were not that bad for you. But of course, this is not the full story. More than 300,000 families lost their home. More than 100 people died. Tweets don't tell you the full story. And the lesson here, it doesn't matter how big is your data source. If you have a bias on the data source, the data will not tell you the full story. And my concern is that there's a huge amount of people out there getting a lot of insights from data sources like social networks without understanding a lot of this data has a huge amount of bias. Bringing us to pitfall number 4. We get fooled by randomness. Ronald Coase, torture the data enough and it will confess. Ronald Coase said that. And what he was referring was the fact that, for example, Leonard Coper was a sports writer back in the 70s. And he found a very interesting correlation. He found that the Super Bowl winner would rightly predict the stock market. So if an NFC team will win, stock market would go up. An AFC team wins, stock market will go down. And until that year, that correlation was perfect. So the question is, do we really believe the Super Bowl could be a good indicator of the stock market? Because if you run a statistical test, you will see that it is statistically significant. How is this possible? Well, the issue here is that if you have enough data, you will find things that correlate just by chance. And this is a good example of this. And if, of course, it's statistically significant because there's millions of time series out there, and we build it to be statistically significant. Let me show you an example of this. This is the hotel occupancy rate in the US. So I took that time series, and I looked for any other time series across Bing that would be highly correlated with this. What is highly correlated with hotel occupancy rate in the US? Any guesses? Cat rentals. Yeah, people are really not renting cats. People are renting caterpillars. But cat rentals are highly correlated with hotel occupancy rate. The issue here is that if you have enough data, you will find things that are highly correlated just by chance. These are spurious correlations. There's no value in them other than people making mistakes. Even after 30 years after Leonard Coper created the Super Bowl indicator, people still report on it. So I'm pretty confident to say that people out there are making decisions based on this. Pitfall number 5, probably the most important pitfall. We forget correlation does not imply causation. There's a very good correlation between ice cream sales and drownings. And this is not a spurious correlation. There's a reason this correlation happens. It's because temperature goes up, you have more ice cream sales, and you also have more people going to the beach, you have more probability of drownings, you have more drownings. These two time series are highly correlated. But if I'm the president of the US and based on this data I decide to ban ice cream sales, of course the only thing that will happen is that the correlation will break. But even though this looks very obvious, majority of the people don't get it. Gallup did a survey a few years ago where they asked, do you believe correlation implies causation? 64% of Americans answered yes. 38% said no, and 8% were undecided. And I'm not worried about the undecided, I'm worried about the 64% that answered yes. And this is so prevalent that you can see it in the press. Last October, there was an interesting paper that these two researchers found a very interesting correlation that how much you spend in your wedding is highly correlated with the probability of divorce. And they say in the paper, it's very clear that they said this is just a correlation. They are not, of course, they're not implying causation. But how did the newspapers read about this? CNN said, want a happy marriage? Have a big, cheap wedding. This is exactly the same as saying, do we want to avoid drownings? Let's ban ice creams. Exactly the same thing. And CNN wasn't alone. The case of cheap weddings, for a marriage that let's try a big cheap wedding. The only one that actually got it right was Wall Street Journal that said, will a cheap wedding help your marriage? A lesson in causation. The lesson here is we need to understand that correlation does not imply causation, and we need to understand the majority of the people don't get it. The second one is that if you're already thinking on having a very expensive wedding, changing your wedding plans probably will not affect you. It's probably too late. Pitfall number 6. We think proving causation from observational data is easy. And I'm going to show you what I call the left-handed dilemma. All right? If we believe that in this class, the probability of being in this class today is independent of the probability of being left-handed, that means that roughly 10% of you will be left-handed. Raise your hand if you're left-handed. You guys are a little biased against left-handed. Well, I have a terrible news for the left-handed people. In 1991, two researchers, Halper and Coren, did a very interesting paper where they took a group of people that died and they asked their family members, a random set of people that died, and they asked their family members whether they were left-handed or right-handed. And what they discovered was amazing. Left-handed people would die 10 years younger, 9 years younger than right-handed people. This was published in the New England Journal of Medicine, that is one of the most prestigious medical journals we have. It was cited and referenced by many other authors. It was even in the New York Times. If this was true, being left-handed was as bad as smoking 120 cigarettes per day. The good news for the left-handed people, not for the researchers, is that they had a problem with it. There was a bias on it. They assumed that the distribution of left-handed people didn't change over the years. And the problem is that for a long, long period of time, there was some sort of discrimination against left-handed people, and parents would force their kids to be right-handed. And my grandfather was one of them. He was forced to be right-handed. Well, eventually they realized that that was stupid, and they stopped doing that. And this generates an an artificial increase of left-handed people in the population that is just artificial. So the problem that this bias generates is that this bias generates a bias against left-handed people, and this is why you observe that left-handed people die younger, when in reality that's not the case. Jim Manzi, in a book that is very good called Uncontrolled, does an extensive analysis of observational studies. And he found that majority of these observational studies, 90% of them, couldn't be replicated. Majority of the observational studies were wrong. It's not easy, it's not trivial to understand causation from observational data, and majority of the time it will be wrong. And this is why, whenever you read the newspaper, this is why we go from coffee is good to coffee is bad for your health, or wine is good. All of these studies are based on observational studies. And majority of them will be wrong. So whenever you read something about an author that is proving causation, the first question we need to ask is, how did we prove causation? Is this based on a control experiment or an observational study? Because if it's based on an observational study, majority of the time this will be wrong. This brings us to the need of experimentation, no more pitfalls. December 12, 1799, it was a very cold day in Virginia. It was freezing rain that day. And a man went to work on his farm like he used to do. He went back to work and he went to sleep. And he woke up in the middle of the night with a terrible sore throat. And because he was a very important person, 3 doctors came to visit him. And these 3 doctors used the same medical treatment, that was bloodletting. What is bloodletting? You open a vein to a patient and you let them drain blood. Today, two days after that, he died. And today doctors believe that what probably killed him was the bloodletting. He was 63 years old, and you probably know him. He was George Washington. We kill him. Daniel Boorstin said something that is very true. The greatest enemy of knowledge is not ignorance, it's the illusion of knowledge. Of course, these doctors didn't want to hurt George Washington, but they were convinced that bloodletting was actually something good for him. In 1836, Dr. Pierre-Louis in France, that's what we probably consider was the first control experiment in medicine. He took a group of his patients, he divided them into 2. One of the groups he used bloodletting, to the other group he didn't do anything. He found, doing this experiment, that bloodletting was actually not helping their patients, was hurting them. And of course, we know that's the case now. Bloodletting was the most common medical treatment, and it was used for over 2,000 years. The reason why you have this in the barbershops, that's the symbol of bloodletting. The red thing is blood. The lesson here is, the question is, how on earth nobody realized over 2,000 years that bloodletting was actually not helping? And the lesson here is, it's not trivial to understand whether something works or not. A lot of these doctors would use bloodletting and patients would get better, but not because of bloodletting, but despite of bloodletting. It's not trivial to understand whether something works. And this is not only something that happens 200 years ago. Qualpro is a company that actually runs experiments to understand whether an idea works or not. In the last 22 years, they measure 150,000 of these ideas. They run 150,000 experiments. Only 25%, these are not any idea. These are ideas that companies are convinced are very good ideas, and that's why they put them in production. Only 25% of them worked. 52% didn't work but didn't hurt, and 22% actually hurt the metrics they were supposed to improve. The lesson here is that if we believe in our intuition to judge whether something works or not, majority of the time we will be wrong. How do we prove causation? How do we prove whether something works or not? The gold standard is a randomized control experiment. What is a randomized control experiment? You took a group of people, you divide them randomly into two. To one of the groups, you apply the factor or idea you want to test, and to the other group, you don't do anything. And then you measure. If there is a statistical significance between the two, then you can prove that that delta was caused by the factor you introduce. You're proving causation. Today, if you go to Bing, Facebook, Google, LinkedIn, you're part of thousands of these experiments. Actually, running control experiments at the massive scales we do it right now is probably the most successful story of big data. Running control experiments is not that hard. What is very hard is for these organizations to allow people to be wrong 75% of the time. And that's not trivial. Because we know that if we run experiments and if you encourage people to run experiments, majority of their ideas will be proven wrong. And if we don't understand that this is just failing is part of the process, then nobody will want to run experiments. And this that looks trivial is actually one of the most problematic part of actually running experiment, is understanding that majority of your ideas, you will be wrong. You will be proven wrong over and over and over again, much more than you will be proven right. So two lessons here. If you need to prove causation and you can run an experiment, you should run an experiment. It's not that hard. And the second one is running an experiment is not that hard. What is hard is to change the culture that will allow people to be wrong 75% of the time. And understand that that's just part of the innovation process. It's about failing fast. Brings us to the third topic, concerns in the big data world. So probably you guys heard the story where a person went to Target to complain that her teenage daughter had received a lot of coupons on pregnancy products. And he asked to speak with the manager and told them, "Are you guys crazy? Why are you sending this to my teenage daughter?" And the manager apologized. A few days after that, the same person called again, and he told the manager that he needed to apologize because he didn't know that he didn't know that his teenage daughter was pregnant. So the story went viral in the world, and people were thinking, wow, how did Target knew that this person's daughter was pregnant before him? This is the power of big data. And if you take a look at the problem from machine learning perspective, this is not a very hard problem. I don't think this story is about the power of data only. I think this story is about privacy. Because privacy is not only about what information is being collected, but how this information is, privacy is about having control of what we share and with whom. And this teenage person didn't want to share that information with her father yet, and Target did it for her. And that's the problem here. even after all the jargon, even after all the hype, the power of data is real. And I'm personally optimistic about the future. And the reason I'm optimistic, Bill Clinton said once, intelligence, ability, and willingness to work are evenly distributed around the world, but opportunities are not. The reason I'm optimistic, at least in the big data world, is because I think that we are doing something on the opportunities part. The first one is opportunity to learn. Sebastian Thorne and Peter Norvig, probably one of the best professors we have of artificial intelligence, in 2011 decided to do an amazing experiment. They had the artificial intelligence course in Stanford, and they decided to massively open this course to any person in the world that had access to the internet. This experiment was a huge success. More than 160,000 students around the world, from Afghanistan to Colombia, actually participated in the course. What is more amazing is that at the end there was a final exam that not everybody was able to finish it. But among the first top 400 students, there was no one from Stanford. So what this tells you is that if you give the opportunity for people to learn, people actually will learn. And thanks to programs like Khan Academy, edX, Udacity, Coursera, people around the world now have access to these type of things. The second one is the opportunity to access processing power. As you probably realize by my perfect English accent, I wasn't born and raised here. I was born and raised in Uruguay, South America. And my parents had the vision and the opportunity to actually buy me a computer when I was very young. And I was able to learn how to code by myself. And I probably wouldn't be here if it wasn't because of that. But majority of my classmates and majority of my friends didn't have access to a computer. But today, thanks to programs like One Laptop Per Child, every single student in Uruguay has access to their own computer. On top of this, you can buy, with $29, you can buy the cheapest smartphone that actually can run much more than a lot of these computers can. So it's becoming cheaper too. Opportunity for accessing data. 10, 15 years ago, even if you had the knowledge and you have the processing power, unless you were working at a university or a company that has data, you wouldn't be able to do anything because you didn't have data. Well, today, thanks to programs like Open Data, countries and organizations around the world are allowing everybody to use their data. And this is also making a huge impact. Another thing is programs like Bill and Melinda Gates Foundation, for every single research they fund, they make sure that all the data assets, once the research is done, all the data assets are open to the public. Last one is the opportunity to focus on the right problems. Jeffrey Hammerbacher, probably one of the first employees at Facebook, and probably the first data scientist, said once, the best minds of my generation are thinking about how to make people click on ads. And that sucks. And he was right. There has been some change. DJ Patel, who was the chief scientist at LinkedIn, is now the chief data scientist at the White House. NGOs across the world that has a huge need for doing something with the data they collect. They don't have the skills nor the money to pay for those skills. But thanks to organizations like DataKind is building pro bono data scientist teams to help these type of organizations. Big data will not be able to solve world hunger, but can help. 40% of the food in the US that is generated in the US goes uneaten. 40%. And the reason this happens is across the chain, there's people making decisions and making forecasting of how much food they're gonna sell. Well, if you can improve, and every single one of these steps, people are making those decisions. If you can improve the data collection, and if you can improve the forecasting algorithm, you can actually try to help these type of problems. Thank you very much.
I want to start off with the first question, because our MBA students and just about every other MBA student at all top business schools they've seen all these pitfalls, right? They know about biases, they know about confusing correlation with causation, and yet, in your experience, they often continue to fall into these pits. What's so difficult about these kind of basic lessons, and how important is it that people learn to avoid these pitfalls?
The biggest problem is that that I see is that if you see some correlation that is obvious, like ice creams to drownings, of course people get it. The problem is when someone is convinced that they have a good idea, their own brain will be biased towards seeing data that will tell them the same story. And if they see something that is correlated, that is aligned with their idea, majority of the time they will think that correlation implies causation. And yes, I assume that a lot of people, that almost anybody has the knowledge that correlation does not imply causation, but we still see a lot of these mistakes happening over and over again, because we need to understand that humans learn from this, correct? We learn, our brain will tell you, like, I work on this. This is my speech, but I have now an 18-month daughter, and for the first 13 months, she wouldn't sleep. And even though I know that correlation doesn't imply causation, for those random days that she would sleep, I would go and try to replicate exactly what she did before. Because again, your brain will tell you, we learn by correlation. So it's something that we need to unlearn. It's something that we need to understand that majority of the times we will be wrong. And we need to challenge ourselves. No, yeah, the data, we are seeing that, and your brain is completely convinced that this is a good idea. But majority of the time, that's not the case. The way that to get that is to being wrong. Like once you start running experiments, if you run 100 experiments and 75% of them fail, you will unlearn that. But until that, we think that we are convinced that this is a good idea. The data is telling us that. So it is hard to unlearn. Questions? Yes.
What is Microsoft doing to create value for the society with big data?
To create value for?
The society that you emphasize here?
Right, society.
For society?
Yeah.
Well, many things, correct? Microsoft employees are probably the biggest donors to NGOs. Like we have donated over $1 billion on that. That's one thing from the employee perspective. On top of that, we have a lot of programs with different organizations, and a lot of them are very successful. So I can give you more details. I don't work in that area. I can give you more details, but definitely they work a lot in education. They work a lot in many of the areas, basically.
Or how do you use data to create value in your products that are generally helping people? You mentioned that code where most of the brilliant minds are working on improving the rates for ads.
Yes.
So what is Microsoft doing differently than that?
We will probably start with Excel, correct? If you ask me today, how much impact can have something like Excel in society? I don't think it's an easy question to answer, correct? But I can tell you that it's huge. Like, the world today runs on Excel. A majority of, everybody here in this class, probably in a few years, will be taking decisions in whatever work you have, probably majority of the things that you will be using is Excel. I'm not sure if that answers your questions, but.
Or what about today? So I know that happened many years ago.
Well, we still investigate Excel, if that's the question. So again, I think that if you reduce the cost, even for example in the case of Bing or Google, correct? If you reduce the cost of someone being able to actually find information, that's also a lot of cost, a lot of impact, correct? A lot of times we don't think, it's not easy to understand the impact of technology. But if you start thinking, how was the life 10, 15, 20 years ago without all this technology, you will see that it is hard not to understand the impact of technology. Like from a doctor that needed to find something, 10, 15 years ago, he actually had to go and read books. Now he goes into a search engine and is able to answer a lot of these questions. So definitely the impact of technology is an important part.
Let me follow up on the Excel.
Yes.
It used to be that you would sell software to the customer, and then your ability to observe what the customer did pretty much ended at that point. I'm wondering to what extent has movement of this product toward a software as a service model opened up all sorts of opportunities with respect to improving productivity?
Yeah, definitely. So before Microsoft, we used to, like in the software era, you used to spend a huge amount of effort thinking of what is the product, like Excel or Word, and then it will take you like 3 years or 2 years to build it, and then you would ship it, and the next iteration will happen in 2 or 3 years. So now, thanks to a lot of these systems happen on something that you can actually change and experiment, first you are able to actually run experiments that before it was impossible, correct? Before, a lot of the times you wouldn't be able to actually run experiments. Now, what is also important is there's a feature that is not working, you can go and change it right now. Like there's no 18 months, 30 months cycle to actually do these type of changes. So it's definitely changing the way that organizations work, that they need to become more agile. That the whole idea of let's spend 3 months or 6 months thinking of what are we gonna do, doesn't happen anymore.
Well, I guess what I was saying is that if you have access to information inside the productivity software of a company, you pretty much understand everything about how that company runs.
Yes.
So could Microsoft then use information that they've gleaned from, all of the users of the Microsoft Office product within an organization to figure out, where are the productivity bottlenecks within that organization?
Yeah, so definitely you can collect a lot of this information and actually understand, like Excel has probably thousands of features and none of here, at least I don't know how to use them all. But there's some features that are more used than others. And every single product we need to decide that. Well, before it was impossible. Either you do a focus group or something that wasn't very based, or you ask questions on a survey. Now we know, because we're collecting that data on, okay, this feature is being used much more than this feature. Let's have this feature on top so people understand and learn how to use it. Yes.
So most of us are not gonna go out and become data scientists, but most of us are gonna work with them.
Yes.
What would be your recommendation on approaching experts in the data world, and how to communicate, what to communicate, and what exactly to be more productive, or what ways could we enhance our work together?
So my recommendation is you definitely need a good working knowledge of things like statistics. Like you need to be able to, like as data scientists will tell you what the data is saying, correct? They will find a trend, or they will find something, I don't know, a pattern or something that correlates with something else. In order to have a constructive, in order to have impact, the other side of the room needs to understand what is really the data telling them. And that doesn't mean that you will need to understand the nitty-gritty of how a machine learning algorithm works. But you definitely need to understand concepts like correlation doesn't imply causation, or concepts like, okay, what is the probability that this is just by chance, correct? Like things like that is very important for the other side of the room to understand it. Not sure if that answers the questions, but yes.
Can you give a couple of example projects that you worked on recently?
On data scientists?
Yeah.
So one of the things we're working that is interesting is gender detection. Basically, it's like people make queries. Can we predict whether someone is a male or a female based on what type of things they search? And this is actually a machine learning problem. Whether we have a group of people that we know whether they are male or female because they are what we call their sign-in, and they provided that information to us. How can we, using that group of people, can we infer the rest of the population where we don't know? That's one of the problems. We're also working in targeting. Basically, like before, you would have a single, let's say, an email campaign. So you would have 1 million people, and you would just spam 1 million people with that email. Now the idea is try to use it in a targeting. You're gonna send an email to someone only if you think that the probability of that person, like it's useful for that person to actually read that email, and there's something that will happen, because just sending by sending, there's more chances that that person will unsubscribe, for example. That's another problem we're working on. And then we're working a lot of these experiments, trying to work with teams to run more experiments. And also, once they run an experiment, try to use the data to understand what is the causality, what is the causality here. Can we prove causality based on these results or not, basically?
Do you guys act more like a consultancy across the entire company?
Yes. So right now, we are probably the only team that is, we used to be just focused on Bing, but now we are focused on more all the Microsoft ecosystem. Even though majority of the effort we're still working with Bing, we're also working with Office, with Skype, with Azure, basically. Yes.
So do you see the skill set of the data scientist, do you see that as a specialized role that will be separated like in the future as well? Or do you think that an all-round profile will be what's like valuable in the future?
What I think is not that it's separate. I think everything is evolving to.
Developer, right? It's like a buzzword, and everyone looks now for the developer that can do everything, right? So the question is like, does a data scientist, should they be able to understand the business side or no, and on the other way around?
So let me tell you one thing. What I see is that majority of the careers at the end have something very much in common, that is they need to work with data. Like, not, I would say, not every single career out there, but majority of the careers, like from a physicist to an astrophysicist, to a mathematician, to a statistician, to an economist. A lot of these have something in common, that is how to deal with data. And now for the first time, a lot of these, they have a huge amount of data, so they have very common set of problems. So to answer your question, I think every single, like within 10, 15 years, every single person that works in a career that actually needs to use data will become sort of a data scientist. And they, on top of that, they will include their knowledge, correct? So MBAs will have much more knowledge on the business side. You will have, physicists will have more knowledge on their side. Economists will have more knowledge on their side. So what at least we are trying to build are multidisciplinary teams. At least in my team, we have physicists, we have astrophysicists, we have PhD in statistics, we have economists.
But you're still a separate team, right?
We work as a separate team.
So the question then would be like, is it still going to be a team in the future that's separate, or does every team have?
Well,
this
is an interesting question I was discussing. Is it goes back and forth. So there is this sort of, let's centralize everything, and then they decentralize and centralize. Like, both of these worlds have pros and cons. What has worked in the past better is where you still have some central knowledge, but these central knowledge each team has their own data science, and that person also works. Basically, it's like more a hybrid approach. I don't know if that's the perfect solution. I think that's, yes.
I have a question. So when you guys are trying to solve problems with data at Microsoft
Yep.
particularly, do you guys use mostly in-house data, or do you also import data from other sources? And if so, like how do you evaluate like the kind of the purity of that data that you get from other places?
So a majority of the data that we have is our own data, but some of the problems require external data. For example, if we want to understand a problem where we're seeing if there's a bias on gender or income, we use census data, for example. Understanding how trustworthy is that data is very hard. And the problem, like, I haven't seen in my life a perfect data source. Every single data source has their own problems, has their own bias, has their own issues, has their own data collection issues, has their own bugs. Getting knowledge of how this data is being collected is key for anyone. Like from an MBA to a data scientist, to anyone working and making decisions out of this data, they need to understand that there will be no perfect data collection system. And understanding at least what are the problems will at least make you a much more informed decision. Let's say if you want to make a decision, well, you need to understand that, I don't know, majority of these data come from surveys that has their own problems, so yes. Yes?
When you think about something like Cortana or People Now, like those things advancing to more, I guess, what people would think of like science fiction, artificial intelligence. Is that more of a, do you see it as like a software development problem, a data science problem, a data engineering problem? Like what is the biggest roadblock into that sort of thing moving to the next step?
Majority of those problems are, well, the problem is that the software developers that you have in those problems are people that have knowledge into machine learning or knowledge on things that you will see in data scientists. Definitely the problem that you have there is how to interpret and how to work with data. At the end, all these problems are data, correct? Like you have Cortana, you have an algorithm that converts that into text, that's a data problem. And then from that text into an action, that's another data problem. So majority of the roadblocks there are data problems, basically.
I guess there's different kinds of data problems, right? There's like the machine learning kind of data problem, and there's the, now I have all of this data, it's completely unstructured, what do I do with it, how do I store it? How do I bring in different data sources?
Yeah, but if you ask me what is the role of the data scientist, is both, correct? So you have data scientists that are completely focused on a single problem, like a machine learning problem for Cortana. Actually, we have a team of data scientists working on that problem. The data scientist is not only the person that sits in a consulting team and gets the data and takes a decision. A lot of times, they are involved with these teams trying to solve and help creating better algorithms, basically. So, yes?
Question. Yeah. I'm just wondering, how big is your team? How fast has it been growing? And do you feel like you don't have enough data scientists at Microsoft right now?
My current team is 10 data scientists. We created a team 2 years ago. From 0, we went to 10. It was hard enough to hire 10 data scientists. For the last 2 years, when Satya joined Microsoft, there has been an increase. Like, we didn't even have a data scientist role in Microsoft 2 years ago. So we created, I was part of the team that actually created and defined the role of a data scientist. Before, Microsoft was, you either were a dev, a PM, or a tester. There was nothing else. And there were data scientists in each one of these 3 organizations, but their career path wasn't very clear because usually a lot of data scientists are not very good devs, definitely not very good PMs or testers. So that's why we created the knowledge, the concept of a data scientist. And now Microsoft, I don't know how many data scientists we have, but we have been growing a lot internally, the amount of data scientists.